வணக்கம். இன்னைக்கு நம்ம சேனல்ல என்ன பார்க்க போறோம் அப்படின்னு பார்த்தீங்கன்னா, ஒரு சூப்பரான விஷயம் என்ன அப்படின்னு பார்த்தீங்கன்னா, ஆல்டோல் கண்டென்சேஷன். இப்ப ஆல்டோல் கண்டென்சேஷன்னா என்ன அப்படிங்கிறத பார்க்கலாம். ஸோ ஆல்டோல் கண்டென்சேஷன் பார்க்கறதுக்கு முன்னாடி what are all the important requirements for aldol condensation? We must understand all those things. Okay, so we can't straight away go and see that aldol condensation directly. So first of all, we'll have to understand what is aldol condensation. It's nothing but aldol condensation. Okay, aldol condensation. Okay, right. So what is the important condition for aldol condensation? That will speak. That is the primary role. Okay, right. So aldol condensation, in the sense, from the word itself, we can identify whether aldehyde group is there or alcohol group is there. But in this case, we have aldehyde functional group is there. At the same time, we have alcohol is there. Clear? So aldehyde functional group, at the same time we have alcoholic functional group. That kind of compounds otherwise called as aldol. Is it clear? Right. So let me move on to from the basic only I am going to talk. So that's what, please be wait. Okay. So from the basic itself I will start this aldol condensation. Okay. Right. So aldol, already I told you, aldehyde functional group is there and alcohol functional group is there. Okay. Aldehyde is there and alcohol is there. Very, very important note. Okay, by just looking at the compound, you can able to find out whether the given compound is aldol condensation or not. Okay, whether the compound is involved in aldol condensation or not, with the help of just by looking at this product itself. Clear? So the first thing is aldol condensation. Let's get into the reaction. What is the important condition for that? The first condition, it must have alpha hydrogen. Okay, alpha hydrogen containing aldehydes. Alpha hydrogen containing aldehydes. Okay, alpha hydrogen containing aldehydes or ketones which involves in aldol condensation. Yes, what do you mean by aldol condensation? What do you mean by alpha hydrogen? So here you can see when the functional group is attached, say for example, let me take one aldehyde which is called as CH3 C double bond O H, which is called ethanol. Okay, ethanol is the name of the compound. Clear? So which one is the functional group here? Here the functional group is aldehyde. Correct? Here the functional group is aldehyde. Clear? So here functional group is aldehyde. So next to the functional group attached carbon is called alpha carbon. Clear? Now the alpha carbon containing aldehyde is there. It's a good example for alpha hydrogen containing aldehyde. Clear? Right. So alpha hydrogen in the sense, so the functional group attached to carbon which is called alpha carbon. In that alpha carbon we have 3 hydrogen, so there is alpha hydrogen containing aldehyde. Clear? Right. And very important thing we know that, so alpha hydrogen containing aldehyde involves in aldol condensation. Clear? Right. Okay. And here it's a good example for aldol condensation, which is this molecule which is going to involve in aldol condensation. Okay, right. And then second important condition, because of this alpha hydrogen is acidic in nature. Alpha hydrogen is acidic in nature. Very, very important concept. What is that? Why it is acidic in nature? Alpha hydrogen is acidic. Say for example, when I am taking carbonyl carbon, C double bond O H is there, and here functional group is there in which hydrogen, hydrogen, hydrogen. Now you know that which one is alpha carbon? This one is alpha carbon, and 1, 2, 3. We have 3 alpha hydrogen, and this alpha hydrogen is acidic. Why it is acidic? It is very simple. Here the carbonyl group, it is electron withdrawing one. So carbonyl group trying to pulls out electron from the carbon. So carbon will pulls out electron from the hydrogen. The H plus will leaves very quickly. That is what the alpha hydrogen should be acidic. Because of this, because of these reactions only, this kind of aldol condensation will be taking place. Here alpha hydrogen is acidic and it must have alpha hydrogen. Okay, if it satisfies these 2 conditions, it involves in aldol condensation. Let's check how the reaction is going. Okay, right. The first thing is reaction. Let me move on to the reaction. First I'll write the reaction, then you can see. alpha hydrogen containing aldehyde. Let me take CH3C double bond OH. It's an alpha hydrogen containing aldehyde. Okay. And this two molecules of alpha hydrogen containing fire. In the second step, what will happen? The second step, what will happen? That CH2 minus, that means that nucleophile will go and attack this second molecule. Second molecule is what? CH3C double bond OH, another aldehyde. Clear? Another aldehyde will be getting. Okay. Now you can see this nucleophile where it will go and attack. Where it will go and attack? The very important thing, the nucleophile always approaches the positively charged carbon. As we know that base always attacks hydrogen. Okay. Base attacks hydrogen because base attacks acids. Okay. But here nucleophile always attacks carbon in organic chemistry. Okay, in organic chemistry, the nucleophile will go and attack the carbon. Clear? Right. Now this nucleophile will go and attack this carbon because it has highly positive charge. Why? Because it is attached with a highly electronegative element. Okay, it is attached with a highly electronegative element. So what will happen? Now the carbon, you see here, carbon 1, 2, 3, 4 bonds are there. Clear? 4 bonds are there. Okay. Now, if the pair of electron will come and attack, it will also form a pair of electron. It forms one bond. So that bond will be cleaved out. Why? Because the carbon cannot form 5 bonds. Okay. The carbon cannot form 5 bonds. That's what it can go like this. So then I can write this molecule. What is that? CH3CO minus, and here it will be H, and then remaining the CH2 will come and attach here. Correct? CH2 will come and attach here, then CH2, CH4 is there. Clear? Right. So finally, if you acidify it, what kind of product we can get? So I'll be getting this kind of product. So CH3, CH, here it is OH, this H plus will come here. Then I can write this bond. Okay, I can write this carbon bond to here. Okay, then CH2, CHO is there. Okay, what is the name of this compound? So it is an aldehyde. Primary functional group is aldehyde. Okay, that's what I can start numbering from here. 1, 2, 3, 4. Okay, so what is the functional group? Aldehyde will get a more priority. Clear? So here 1, 2, 3. 3 hydroxy. How many carbon atoms? 4 carbon atoms. So the name of the compound will be 3-hydroxy butanol. Clear? 3-hydroxy-butanol is the name of the compound. Clear? Very, very important. Okay, note it down. Then next we'll move on to the tricks. Okay, so how we can find out the aldol condensation just by looking at the reactant. Okay, let's see the trick. Interesting trick. Okay, note it down. Yeah, let's move on to the next thing. So in the first step, so just I repeat once again. So here 2 molecules of alpha hydrogen containing aldehyde will involving in the presence of base. It forms aldol as a product. So in this, the first molecule which is reacting with a base to attract the alpha hydrogen. So H plus will move off, it leaving behind the electron itself. That electron will be transferred to this carbon, so that way it forms a nucleophile. This new formed nucleophile will attack the second molecule because we have taken 2 molecules. One molecule which will be attacked by nucleophile, base. Another molecule will be attacked by this nucleophile. Okay, this nucleophile will come and attack the second molecule, but it forms a product which is called 3-hydroxybutanol. Clear? Right. So let's check how we can find the product. Okay, let's see. The first thing, it will be simple trick. Okay, it's a simple trick. Just by looking at the reactant, we can able to find out the products. Okay, let's see how it will be. Say for example, when I'm taking 2 molecules, CH3, C double bond OH. Okay, if another molecule will also be same, CH3, C double bond OH. Okay, just you look at very simple trick. What is that? Just remove alpha hydrogen from one molecule, and this transfer this molecule into here. That hydrogen will be added here, that entire group will come and add here, okay, or the entire group will come and add here. What kind of product we can get? I can get this product like this. You can see here, this CH2 minus will come and approach here. So what kind of product I can get? So CH3, C double bond OH is there initially. Here CH3 is there. Okay. Just I'm taken one hydrogen from here, that will be added to this oxygen. Okay. Then remaining thing will be attached to this carbon. So what I will get? So CH3, COH, here it will be H, and here CH2, C double bond OH. That's it. Very simple trick. It's a very simple trick. We can able to find out the product. Okay. It's a simple trick to find out the product. Okay. What kind of, whatever the aldehyde is given, different aldehydes are given. If suppose if it involves in cross-aldol condensation also, we can able to find out the product. Let's check. Suppose if we have a molecule like this, CH3, C double bond OH. This is one aldehyde. Okay. Suppose another aldehyde if I am taking CH3, CH2, C double bond OH. Actually, this cross-aldol condensation will form some 4 different products because both are containing alpha hydrogen. Clear? So in this case, you can look at, this is a functional group, this is an alpha carbon. This is a functional group, this is an alpha carbon. Both the reaction involved aldehydes are containing alpha hydrogen, so that it can give 4 different products. We'll see that cross-aldol condensation different live. Okay, right. And here how we can find the product. Simple, just what I told you here, alpha hydrogen, just remove an alpha hydrogen and add that alpha hydrogen to this oxygen and remaining to this carbon. That's it. Okay, so what kind of product we can get? So I'll be getting CH3, CH, here OH. Okay, to this carbon, which group is coming? The CH group is coming. So I can write CH group. CH group I'll be to be attached with one side CH3, another side aldehyde. That's it. Okay, we can get a product like this. Is it clear? Very, very simple. Okay, is it clear or not? Very, very simple. Okay, right. Okay, then what kind of molecules which are going to involve in aldol condensation? Let me check. So what is an important simple trick? So the molecule, just I am going to write a molecule. You just check it whether the molecules are involving in aldol condensation or not. Okay. First condition, first molecule is CH3, C double bond OH will be there. This is ethanol. Okay, this is called ethanol. Okay, and this ethanol will involve in aldol condensation or not? We have to check it. Okay. Then second molecule CH3, CH2, C double bond OH. Propanol. That propanol, whether it is involving in aldol condensation or not, let's check. Third one it will be. If it is benzaldehyde, C double bond OH. Okay, this is another molecule. Then fourth one is 2-methyl propanol. They given the name of the compound is 2-methyl propanol. Okay, whether the molecule is involving in aldol condensation or not, that is what the question is there. Okay, whether all these molecules are involving in aldol condensation or not, let's check. Okay, and then fifth one it will be, suppose the molecule may contain this kind of thing, CH3, C, CH3, here CH3, here C double bond O, here C, CH3, CH3, another CH3 will be there. Okay, whether this ketone involving in this kind of a condensation reaction, let's check how it will be there. Okay, yes Kana, hi. Yes Kana, hi. So then what kind of things are involving in this aldol condensation? What is the important condition for whether the compound is involving in aldol condensation or not? Simple trick. So it must have alpha hydrogen. First you have to check whether it is having alpha hydrogen or not. Okay, right. Check it down whether this having alpha carbon. Yes, alpha carbon, 3 alpha hydrogen is there. Yes, definitely it involves in aldol condensation. No doubt in it. Okay, second molecule, check it down. So here alpha hydrogen is there. Yes, it involves in aldol condensation. Okay. What about the third one? Whether it does in it will involve in aldol condensation or not? Actually, it does not involve in aldol condensation. It does not involve in aldol condensation. Why? Because benzaldehyde doesn't have any alpha hydrogen. Alpha hydrogen containing aldehydes and ketones only involved in this kind of condensation reactions. But here, benzene ring. You look at the benzene ring. So, what is the formula for benzene ring? 1, 2, 3 here. And here C double bond OH is there. Clear? Right. What is the molecular formula for this? So it is nothing but C6H5CHO. Clear? Right. So instead of that C6H6, instead of that one hydrogen, this aldehyde group is coming. Clear? Okay. Now you see here 1 carbon, 2 carbon, 3 carbon, 4 carbon, 5th carbon, 6th carbon. Yes, 6 carbons are there. Correct. Okay. Whether it has any hydrogen, let me check. 1 hydrogen, 1 more hydrogen, 1 more hydrogen, 1 more hydrogen, 1 more hydrogen. But here instead of this hydrogen only, this entire group is coming. Correct? Instead of this hydrogen only, this entire group is coming. That's what it doesn't have any alpha hydrogen. It has alpha carbon, but that doesn't have alpha hydrogen. If it is not having alpha hydrogen, that does not involve in aldol condensation. Clear? So this molecule not involving in aldol condensation. And next one is a 2-methyl propanol. Yes, 2-methyl propanol. How we can do that? How we can do that? 2-methyl propanol. 2-methyl propanol. How we can write the structure? Propanol in the sense 1, 2, 3 color. Okay, and it is aldehyde. CHO will be there. 2-methyl propanol. In the second question we have CH3. Here CH3, again one hydrogen is there. Whether it is involving in aldol condensation or not? Whether it is involving in aldol condensation? Definitely. Why? Because it is called alpha hydrogen, alpha carbon. Alpha carbon is having alpha hydrogen. So definitely this molecule is going to involve in aldol condensation. Okay, this is a simple trick. Just you look at the alpha hydrogen is there or not in the molecule. In the aldehyde or ketone, if it has any alpha hydrogen, definitely that molecule is going to involve in aldol condensation. Clear? Right. Okay, whether this molecule is involved in aldol condensation? Now check it out. Sure, then yes, class 12 haloalkane halo rings, we are going to start soon. Okay, so for board 2024 we are going to start from the first chapter of organic chemistry itself. We are going to start. Okay, from June 1st onwards you will be getting a video regularly. Okay, right. And then whether this molecule is involving in aldol condensation? Actually not. Why? Because functional group is there, but alpha carbon is there, but in that alpha carbon there is no alpha hydrogen, so this molecule doesn't involving in aldol condensation. Clear? Aldol condensation will not be there. In that molecule the aldol condensation is not there. Clear? Very, very important. Okay. Then suppose this molecule, sixth one, let me check. HC double bond OH. What is the name of the molecule? The name of the molecule is formaldehyde. Whether this formaldehyde involving in aldol condensation or not? Definitely not. Why? Why doesn't involving in aldol condensation? Because this is a functional group. There is no alpha carbon itself. There is no alpha carbon. Look at, there is no alpha carbon. If there is no alpha carbon, there is no alpha hydrogen. Okay. If there is no alpha carbon in the sense, there is no chance of getting alpha hydrogen. So that it does not involving in aldol condensation. Clear? If this molecule will not involving in aldol condensation. Clear? Right. And the next molecule, let me check. The next molecule, cyclohexanone. Cyclohexanone. Whether this molecule is involving in aldol condensation or not. Let me check how it will be. Say for example, this is a functional group, C double bond O. This one is a functional group. Functional group attached to carbon is alpha carbon, and here also we have alpha carbon. Clear? So what is the molecule? Here we have 1 carbon, 1 carbon, 1 carbon, 1 carbon, 1 carbon. Okay, this is an alpha hydrogen. Clear? This is an alpha carbon. In that alpha carbon we have 1, 2 hydrogen is there. Okay, here in this molecule also We have two hydrogens there. So which consists of alpha hydrogen. Definitely this molecule is going to involve in aldol condensation. The very important condition what it is, it must have alpha hydrogen. Alpha hydrogen containing aldehydes and ketones are involving in this aldol condensation. Clear? Let me check. Ethanol. Ethanol. Whether it is involving in aldol condensation or not. Can anyone? Yeah, ethanol, whether ethanol will involving in aldol condensation or not. Ethanol. Actually, ethanol does not involving in aldol condensation. Why? Because we know that ethanol, say for example, CH3, CH2OH. Clear? This is an ethanol molecule. Whether it is involving in aldol condensation, actually I told you it does not involve in aldol condensation. Why? Because it has alpha hydrogen, alpha carbon, alpha hydrogen is there. But it is not an aldehyde, it's an alcohol. Clear? It's an alcohol, so that it is not involving in aldol condensation. Is it clear? The questions are always NEET questions, board questions, everything. NEET, this last 2023 NEET question, all the questions coming from only NCERT. Okay, don't deviate any other concepts. Okay, please go with NCERT. That's my kind advice. Okay, please don't do that. No need to study much. Okay, just you have to be thorough with entire concept of NCERT. If you thorough with it, definitely you can rock it. Definitely you can clear the NEET also. Okay, so I think so. Definitely you understand this concept. Thank you so much for watching. Thank you.